Alright everybody, what's up? This video we are going to look at strategy for integrals. So the integrals in this video tend to be a little more difficult than the ones you normally run across. So let's go ahead and get started. We got about 4 or 5 examples to work. So the first thing I want to bring up is the table of integration formulas, which is all of these right here. All right, you've got to know them. All right, if you don't know them, then you're not going to be able to work the problems. I know, like here we've got inverse tangent, inverse sine, but there are others, and you can look those up in your calculus book, but these are the ones I've written down. Like for instance, you probably want to know what inverse cosine is. Okay, and you know, and some other ones, inverse secant, inverse cosecant, inverse cotangent, those formulas. But the point I want to get across to you is, in order to integrate, the problems that we're going to be working, they're not going to be in any of the forms from this table. And so what we have to do is rewrite our problem to get them into this form. That's really the whole key to it, is when you're integrating, you've got to make it look like one of these formulas, and then we can integrate it. And you know, you've learned different methods so far. You've learned the trigonometric integrals, you've learned parts, trigonometric substitution, partial fractions. Okay, those are the techniques that you have to apply, or that you may have to apply. Oh, and also U-Substitution. Those are the techniques that you may have to apply in order to get the problem into one of these forms here, so then we can apply these formulas here. All right, now some things to think about: the strategy. So simplify the integrand if possible. Okay, so whatever you're integrating, just, you know, try to simplify that function if you can. Look for an obvious substitution. Okay, you might just be able to use U-Substitution and that's it. Classify the integrand according to its form. You know, what might you need to do it. Okay, and try again. Okay, you may have to, so you may be looking at substitution, U-Substitution, parts, manipulate the integrand, relate the problem to previous problems that you've worked, and you may have to use more than one method, okay, to get it. All right, so let's go ahead and look at this. So we've got tangent cubed over cosine cubed, and this is a parenthesis right here. All right, so let's see what we can do. So this particular problem, I'm going to actually work it 2 different ways to show you on some of them it's not just one way to work it. All right, so the first thing we're going to do here is we're going to write this as secant cubed tangent cubed dx. Okay, that looks kind of familiar because, you know, up here we have, you see this secant tangent? I don't know, it might work. I know we have secant cubed tangent cubed, but let's see what happens. Well, notice how we have an odd power here. So what I'm going to do is I'm going to rewrite this as secant squared x tangent squared x. I'm going to save a factor of secant x tangent x. All right, so I'm writing the secant cubed as secant squared times secant, and the tangent cubed is tangent squared times tangent. Now notice here how I have secant times tangent. Well, the derivative of what is secant tangent? Well, the derivative of secant, right? The derivative of secant is secant tangent. Well, I have a secant here, a secant squared, but here I have a tangent squared. But I know that I can rewrite that. So I write down my secant squared, and then tangent squared, I'm going to write that as secant squared x minus 1. Because remember your formula, 1 plus tangent squared is equal to secant squared. And I just move the 1 over. And then that's secant x tangent x dx. And so now I can make a U substitution. U is equal to secant x, so du is equal to secant x tangent x dx. So now I can replace, you see the secant tangent dx, secant tangent dx, I can replace all of that with du, and then I can take the u and plug it in for secant. So let's do that. So I'm going to get u squared times u squared minus 1, and then I'm going to replace this with du. Okay, so I just plugged u in for secant. And so this is going to give me u to the 4th minus u squared du. And that's going to be 1/5 u to the 5th minus 1/3 u cubed plus c. And then I have to do what? I have to get it in terms of x, my final answer. So I'm going to put secant back in for u. And so that's going to be 1/5 secant to the 5th x minus 1/3 secant cubed x plus c. All right? And here's our answer. All right. All right, so that's one way to work it. And, you know, probably the easier of the two methods that I'm going to show you. And, you know, I would recommend working it just like I did. But let me show you another way to work it. So we have the integral tangent cubed x over cosine cubed x dx. All right, so the way I'm going to go about working this is, if you remember back when you were proving trig identities, you know, if you had pre-calculus or took a trig class, one of the first things you did when you verified identities is you would rewrite everything in terms of sine and cosine. So tangent cubed, I'm going to write that as sine cubed over cosine cubed. And then see the cosine in the bottom? That's the same thing as 1 over cosine cubed. So that's times 1 over cosine cubed x. Let's put our integral symbol, dx. And that is equal to sine cubed x over cosine to the 6th x dx, and put our integral symbol. All right, so it looks like it really didn't help much, but if we look at this, we've got an odd power on the sign, so let's save a factor of sine. So this is going to be sine squared x over cosine to the 6th x times sine x dx. Now, the derivative of what is sine? Well, we know the derivative of cosine is negative sine, right? So let's get this part right here all in terms of cosine. And so that's going to be 1 minus cosine squared x. I just rewrote sine squared x as 1 minus cosine squared, because remember, sine squared plus cosine squared is 1. And I just solve for sine squared, and that gives me 1 minus cosine squared. And that's over cosine to the 6th, and then times sine x dx. All right, so now let's use our U substitution. So I'm going to let u equal cosine x. So du is negative sine x dx. All right, so you can see here I have negative sine x dx, but up here I have positive sine. So I can multiply by -1, and if I do that, then I have to come out here and multiply by -1. All right, so this is going to give me negative, and now in the place of cosine, I'm going to put u, and in the place of negative sine x dx, I'm going to put du. And so that's going to be 1 minus u squared over, and then I've got u to the 6th du. Now we can integrate this. Well, what do? Well, let's split it up. And so, and I think what I'm going to do here, I mean, you don't really have to do this, but you know, let's get rid of that negative there. Let's distribute that negative throughout the numerator. So that's going to be the integral of u squared minus 1 over u to the 6th du. So that's going to be -1 positive u squared. There it is. All right, so now I'm going to get let's do it like this. u 1 over u to the 4th minus 1 over u to the 6th du. All right, so u squared over u to the 6th, that's going to reduce to 1 over u to the 4th, and then minus 1 over u to the 6th. And then to integrate that, that's going to be u to the -4 minus u to the -6 du. I moved this and this up into the numerators. All right, so now we can use the power rule. So that's going to be u to the -3, add 1, multiply by the reciprocal of the new exponent, minus, and then u to the -5, multiply by the reciprocal of the new exponent, plus c. All right, and so this is going to give us, let's write it like this, 1/5 times 1 over u to the 5th minus 1/3 times 1 over u cubed. All right, I just made the exponents positive, and I wrote this one first. A negative and a negative is positive, and plus c. And so this is going to be 1/5, and now what am I going to have to do? I've got to plug cosine. See, plug cosine back in for u. So that's going to be 1 over cosine to the 5th x minus 1/3 times 1 over cosine cubed x plus c. And then we know 1 over cosine is secant, right? And so that's going to give us 1/5 secant to the 5th x minus 1/3 secant cubed x plus c. And there's your answer. And you can see it matches the answer we got before. So you can see sometimes there may be more than one way to do it. Find the easiest one. And, you know, as far as I'm concerned, I think the first way we did it's easier. But I just wanted you to see both of them. All right. So now let's look at this one, the integral of e to the square root of x. All right, so typically when we have e to a power, a lot of times we use U-Substitution, okay? And typically what we do is we let u equal whatever that exponent is. So I'm going to come down here and I'm going to let u equal the square root of x, all right? And let's go ahead and square this. This tells me that u squared is equal to x, right? If I square both sides. And then if I differentiate both sides, I get what? I get 2u du is equal to dx. So let's make these substitutions and see what happens. Okay. So you know, whenever you do U-substitution and you're letting U equal the square root of something. Now, I'm not saying every single time you need to square, like we did here. Not every single time you won't have to do that, but that's something you can try. Okay? All right, so let's make the substitution. So that's going to be the integral e to the u. All right, so in the place of square root of x, I put u. And then in the place of dx, well, what's dx? Well, dx is 2u du. 2u du. And so let's just write this as 2 integral u e to the u du. I'm going to bring that 2 outside the integral symbol. All right, so, well, look at this. That ought to look familiar to you. Parts. Let's try it. Now, remember you got let u equal something and dv equal something. But since this is a u here, let's use w equal u and dv is equal to e to the u. Is e to the u du. So dw is equal to du and v is equal to e to the u. So that's going to give me 2 times, and so I've got w times v, so that's going to be u times e to the u minus, and then dw times v times the integral of e to the u du. And so this is 2 times the integral u e to the u minus, and then I can integrate this. This is e to the u plus c. And so now let's distribute the 2. Okay, let's distribute the 2. And then in the place of u, I'm going to put in square root of x. All right, so, and then also at the same time, I'm going to distribute that 2. So that's going to be 2 square root of x, e to the square root of x, minus e to the square root of x. Whoop. Got to distribute the 2 to this also, plus c. And there's our answer. All right. All right, so that one wasn't too bad. All right, so now let's look at our next problem. Uh-oh. We probably recognize something like this. This right here, when we see this, there's no obvious substitution here. I mean, the derivative of the denominator, that's not going to give us the numerator. Okay? So when we see this, the first thing we probably think of is partial fractions, right? All right, so let's use partial fractions. Well, remember, the degree of the denominator has to be larger than the degree of the numerator. So we need to divide this. So we've got x cubed minus 3x squared minus 10x plus 0. And then here we've got x to the 5th plus 0 times x to the 4th plus 0 times x cubed plus 0 times x squared plus 0 times x plus 1. And we do the long division. Okay, you should know how to do long division by now. All right, you had a section on partial fractions. And actually, I think it's the section right before this one. So you just did partial fractions. Most of you anyway. All right, so and look, if you need more help on how to divide this, go search my channel for long division of polynomials and you can watch that video. So here we've got x squared, and so this is going to be x to the 5th minus 3x squared minus 10x plus 0 times x squared. And then remember, you change the sign of each term down here and add. So that's going to be 3x squared plus 10x plus 0 times x squared, and then bring down the next term. And then this is going to be plus 3x. And then that's going to give us, oh, I'm sorry. Look what I did. How about that? See that squared there? That should be x to the 4th. This should be x cubed. Sorry about that. And so that's x squared, and that's x cubed. I'm sorry, not x squared, x to the 4th. All right. So that's going to give me 3x to the 4th minus 9x cubed minus 30x squared plus 0 times x. And so I'm going to add. I'm going to change the sign and then add. So that's 19x cubed plus 30x squared plus 0 times x, and then bring down the next term plus 1. And so now I've got plus 19, and that is going to be 19x cubed minus 57x squared minus 190x plus 0. And then I'm going to change the sign of each term and add. So I get 87x squared plus 190x plus 1. And so there's my remainder. Okay. So my solution here is this plus the remainder over the divisor. All right. So I'm going to erase this and write that out. Okay. It's going to equal, so remember, this is going to equal this plus this over this. And I'm going to erase this and write it so we'll have enough room to work the problem. All right, so here's our answer, okay? It's this is equal to this. So we know how to integrate each one of these terms. Those are easy. But this one, we have to apply partial fractions. So the first thing I need to do is I need to factor this denominator here. So I get x cubed minus 3x squared minus 10x. That's equal to x times x squared minus 3x minus 10, which is x. And then this factor is pretty easy. That's x minus 5, x plus 2. All right. So we have x to the 5th plus 1. I'm sorry, not x to the 5th. All right, remember, we're just working with this part right now. That's all we're working with right now. And then we'll put it all together. So I get 87x squared plus 190x plus 1 over x times x minus 5 times x plus 2 is equal to a over x plus b over x minus 5 plus c over x plus 2. All right. And then we multiply everything through by the common denominator, which is this. And so that's going to give me 87x squared plus 190x plus 1 is equal to a times x minus 5 times x plus 2 plus bx times x plus 2 plus cx times x minus 5. And then, so now we're going to let x equal 0 because that's going to knock out this term and this term, and I'll be able to solve for a. So that's going to give me 1 is equal to negative 10a. So I take the 0, I plug it in this side for x, and that gives me 1. And then I plug the 0 in here, and that gives me negative 10 times a. And so I get a is equal to negative 1 over 10. And then we're going to let x equal 5 to knock out that. See, that'll make that go to 0. So this term will be gone, this term will be gone, and I'll be able to solve for B. And so when I do that, all right, so I plug 5 in for x into this one. You probably have to get your calculator out to do that. So that's going to give me 3126 is equal to, and then when I plug the x into here, I get 35b. And so I get b is equal to 3126 over 35. Yes, this one has some nasty numbers. That's going to happen sometimes. And then I'm going to let x equal -2. So I'm going to take the -2, plug it in here for x, and that's going to give me -31 is equal to, and then I plug the -2 into this one, and that's going to give me 14c. So I get c is equal to -31 over 14. And now we are ready to integrate this thing. So when we integrate, that's x to the 5th. X to the 5th plus 1 over, what was it, x cubed, let's see, minus 3x squared minus 10x minus 3x squared minus 10x dx. That is equal to the integral. So remember, when we divided that, we got what? We got x squared plus 3x plus 19, x squared plus 3x plus 19 dx. Now, I can plug each one of these numbers here in for a, b, and c. All right, and write that as an extension here and put dx. But what I'm going to do is I'm going to go ahead and split it up. So that's dx plus, and now I'm going to plug the -110 in, the -1 over 10 in for a. But what I'm going to do is I'm going to do minus 1/10 integral dx over x. I'm going to bring that -1/10 out of the integral symbol. And then I'm going to plug the 3126 over 35 in for b, so plus 3126 over 35 times the integral. See, that's b. That's going to be dx over x minus 5, dx over x minus 5, and then minus the 31 over 14 times the integral of dx over, and that's going to be over x plus 2. And now we're ready to integrate. So this is going to be what? This is going to be 1/3 x cubed plus 3/2 x squared plus 19x minus 1/10. And then we know what this, and this are. That's just natural log, right? So that's natural log absolute value of x plus 3126 over 35 times natural log x minus 5 minus 31 over 14 natural log of x plus 2, and then of course plus c. About ran off the page there, didn't I? All right, so that's that problem. All right, so that's not too bad. All right, we've got 2 more problems to work. All right, so let's look at this one. So remember, a lot of times what you want to do is, whenever you see something in parentheses raised to a power, a lot of times we let u equal that, right? And you can see down here we have the square root of the natural log of x. That's the same thing as natural log x. It's the same thing as this, natural log x raised to the 1/2. All right. Well, if I look at natural log x, what's the derivative of that? The derivative of that is 1 over x, right? Well, look at this. And I know you don't have to rewrite it like this, but I'm going to do it so you can see it better. So isn't this, if I rewrite this, isn't this the same thing as 1 over x times 1 over square root of natural log x dx? You see that? I just split it up. That's all I did. Well, what's the derivative of natural log x? It's 1 over x. There it is. So we can just simply use U-substitution here. So we've got u is equal to natural log x. So du is 1 over x dx. So look at there. Let's make our substitution. 1 over x dx. And there's 1 over x dx. I can replace that with du, and then I'm going to put u in the place of natural log x. So this is going to be the integral of 1 over square root of u du. And now we get what? The integral u to the negative 1/2. Remember, square root of u is u to the 1/2, and then I'll move it up into the numerator, du. And so this is going to give me what? U to the positive 1/2, add 1, multiply by the reciprocal of your new exponent, plus c. And so that's going to be 2 natural log of natural log x, and that's square root. I just put natural log x back in for u, and instead of writing to the 1/2 power, I just wrote as square root of x. And don't forget your plus c. All right. All right, last problem right here. All right, so what about this one? This one looks kind of complicated, doesn't it? Well, what I would do here is, you see the x, the 1 minus x and the 1 plus x. Maybe what I would try here is multiplying by, whoop, what did I do there? Okay, what I might try to do on this one is I might try multiplying by the conjugate of the denominator. And if you do that and that doesn't work out for you very, very well, try multiplying by the conjugate of the numerator. Okay? I mean, you just got to try these things. And I'm telling you, the more you work, more you integrate problems, the better you're going to get at it. And, the better you'll know the techniques and all that stuff. All right, so let's first write this. Let's split up the fraction. And then I'm going to multiply numerator and denominator by the conjugate of the denominator. So I'm going to multiply this by square root of 1 minus x over square root of 1 minus x dx. Don't forget you've got to put the square root or you can't multiply them. They both have to be under the square roots. And so now I'm going to get the integral of 1 minus x over the square root of 1 minus x squared dx. Because remember, this right here, the square roots are just going to go away. And then 1 plus x times 1 minus x is 1 minus x squared. All right, so this is looking kind of familiar here. And I'll tell you another reason why that crossed my mind to multiply by the square root of 1 minus x, the conjugate of the denominator, because I knew I would get a 1 minus x squared in the denominator, and that it looks familiar. So if you think about it, let's go back up here. Square root of 1 minus x squared. Okay, square root of 1 minus x squared. Where is it? Look at this. You see this? Square root of 1. So 1 squared is 1 minus x squared. All right, so that's why I did it. Okay, or one of the reasons. All right, so let's go back to our problem. All right, so now what we're going to do, I mean, really it didn't help us much the way we have it written now, but I can do this, 1 over the square root of 1 minus x squared dx minus the integral of x over the square root of 1 minus x squared dx. I can split them up. And I know this right here, that's the formula. That's inverse sine x. See, a is 1, All right. So this is just inverse sine. This one over here, I'll use U-substitution. So let's do the U-substitution on this one over here. So I'm going to let u equal 1 minus x squared. So du is negative 2x dx. All right, so what do I need? I have x dx. I need negative 2x dx. So I need to multiply by negative 2, so that means I have to come out here and multiply by negative 1/2. And so this is going to be the integral 1 over square root of 1 minus x squared dx. And then that's going to be plus 1/2 the integral of, and that's going to be du over the square root of u. All right, so now let's integrate. So that's going to be, well, we know that's inverse sine x, and then plus 1/2. And then keep in mind this, you've got to write that as this. I guess I should have wrote, let's put that step in. So that's going to be 1 over square root of 1 minus x squared. I'm trying to do some of it in my head, I guess. So that's going to be plus 1/2 integral u to the negative 1/2 du. Okay, so you might want to add this step in if you're taking notes. All right, so let's integrate that. So we're going to add 1 to the exponent, multiply by the reciprocal, plus c. And so that's going to give me inverse sine x plus, that goes to 1. And then in the place of u, I'm going to put 1 minus x squared. And I'm going to put it as 1 minus x squared. The square root of that, I just changed the 1/2 to a square root, plus c. And this is your answer. All right, so that's strategy for integrals. And I'll say in the calculus textbooks, this section here, the problems are, a lot of them's difficult, but basically what it is it's all the stuff that you've learned. Okay, just the basic integrals, the U-substitution, trigonometric integrals, trigonometric substitution, parts, partial fractions. All of those problems are in this section. Okay, they're all in this section, all mixed up. So this is a really good section for you to go practice if you wanna learn it. I mean, just start by working out the odd problems, because I would imagine those answers are in the back of the book. You can look them up. All right, so I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see y'all in the next one. Later.